Good evening. This is Nagarajan. Happy to meet you all once again. Is my voice clear to you all? Can you please raise the hands? Hope the voice is clear to you all. Can use the raise hand button. Okay, good. And we will continue with the simulation sessions. Last week, we have seen almost 14 simulations in 3 sessions. Soniji also took. Evaraina practice chesara? Did you try on your laptop or tablet or mobile phone? Anybody tried that simulation? The links were published in the groups. Anybody tried? Okay, probably you might not have got time, but definitely what we will do is we will put all the links in one file and then push it to you and then share. That way you can have it reference. Okay, we will start the session today. I'm going to start some interesting simulations today. I'm sharing my screen now. Ganesh, hope my screen is now visible. If you can
Yes,
tell
sir.
me. Perfect. Today, the first simulation is going to be energy forms and changes. We know electrical energy, heat energy, kinetic energy, light energy. There are different forms. And it gets converted from one form to another. We will see that. I'm going to take the first portion. If you see here, I have water, olive oil, and then I have a lamp or heat source and cooling source below that. There's an iron and brick. Again, this can be used to teach various things. For example, I take the brick and the iron pieces over here, and I take one thermometer here, keep it here, another thermometer here. Okay, now let me check all these things so that you will see what is the kind of energy when the thing happens. I will show that also to you. Now what I am going to do is I am going to heat it. I am heating both. Okay, when I am heating both, the temperature increases. Okay, so actually I would have pressed this thermometer because I put the thermometer slightly away, so it was not increasing. Now you could see the temperature rising. Now when I put the energy symbols here, right? Now what happens is when the heat happens, it absorbs the heat, and then the heat energy, it doesn't change. It conducts the heat, it emits the heat. That's all. There is not much change in that. Now let me do one thing. I am putting them back and taking it back. Now I am taking water and olive oil. Okay. Now I could say water and olive oil. Same way, let us take the thermometers. Okay. I am going to heat it once again. Now you could see the temperature increasing, right? When the temperature is increasing, let us watch. Now I'm changing the energy symbols over here. Okay. When we put this one, water starts boiling, and you could see a state change. here the heat energy is here, and the heat energy, because of that, now the liquid is changing into vapor, water vapor or steam, and it is coming out. That's a state change. But what is the other energy changing over here? If you could see here, these the symbols E, they are moving slightly here and there, whereas in the brick and in the iron you don't see that. That means the water, when it is getting boiled, or when the olive oil, when it gets boiled, inside that there is a movement. Because of the heat energy, there is a kinetic energy gain in the water liquid as well as in the olive oil liquid, right? So again, only the energy changes over here, whereas you won't see that. You know, when water is boiling, you could see the convection happens. It moves from bottom to top and then it moves back again. The convection happens. Same way, within the iron bar also, the convection will happen within the iron bar. But you won't see the particles actually moving inside a solid. Whereas in liquid, there is a kinetic energy change. This is a first introduction. So heat energy, it is getting transformed into kinetic energy. This is one part. Now I am coming back. Let me copy paste this link once again. I'll show you one more interesting thing over here. There is something called a systems. Now you see the system here. In this system, you could see a wheel attached to a cycle. Okay. With this wheel, there's a generator attached to it. With this generator, there is a vessel with water, and then you could see thermometer. Now, somebody is pedaling this. So let me do this. When I slowly do the pedaling, this is a rotary movement. This rotary movement causing a rotary movement here. So some amount of the motion is applied over here. Because of that, electricity will be produced by the generator, because this wheel, this is a generator. Now let me click on these energy symbols. Now you could see the energy is coded in different forms. Okay. So this is this E, right? In the body, we are burning calories. There is a chemical energy, right? And then it causes a mechanical motion over here. And that mechanical motion, because of the generator, it gets converted to electrical energy. Correct? That electrical energy passing through this heater causes thermal energy. Correct? So you could see, but it's all invisible. We cannot see. We can feel the calorie burning by sweating. We can actually see the movement over here. But so many conversions are happening over here. For the kids, it will be interesting. Now, I am replacing this cycle with the penstock. Okay. The other day we have seen the Faraday's stuff, right? And now, instead of this water, I am putting it as an electrical bulb. So this electric bulb is attached. Now I am opening this tap. Again, a mechanical energy rotation happens. It is converted into electrical energy. That electrical energy directly goes through this filament. This filament converts that electrical energy to heat energy or thermal energy, then in turns it is emitting light. It converts to light energy. Correct? So this is the way of showing to the people, because animation is just a video. It shows only the things in motion. Animation is better than the picture. Picture is better than text, right? That's why you used to say a picture is worth 1,000 words. So picture is better than text. Animation is better than picture. Simulation is better than animation. Now let me do one more change. I am changing this to sun. This source is sun. Now what I'm going to do is, instead of this motion, I'm changing it to solar. Okay, I'm changing it to solar energy. I'm taking a different bulb. Now if you see here, from solar, light energy is coming, right? That is getting converted to, now cloud is nothing. Because of the solar panel, that gets converted to electrical energy. That electrical energy passes through this thing. Bulb is glowing. Bulb is emitting light, right? Now bulb also emits heat. Bulb, when it consumes the electricity, it consumes electricity and then it is also emitting light and heat. Now I am mimicking cloud. More cloud is coming, right? If I have a lot of cloud, then because of the cloud, this sun rays is not actually fully falling on the solar panel, so the electric bulb has become dim. Now I remove the cloud. Slowly I remove the cloud. So more light energy is falling on the panel, and because of that it produces more electrical energy. Then you could see the bulb glowing better, brighter. So this is a way to show, as we walk in our day-to-day life, whether it is fan, whether it is air conditioner, bulb, everything has some amount of energy transformation happening in between them. I am stopping my screen. Coming back to video. So how is it? The first simulation that we saw today, do you like it? Can you raise the hands or can you type it in the chat about how did you like this simulation? Forms of energy getting changed. I would like to hear your response. You can also raise the hands. You can also type it in the chat box. Either way, it is fine. Good, right? I don't see even a single hand raising. That's very surprising. There are about 95 people attending, and I would like you to participate. Do you see this interesting and easy to explain to the kids in terms of transformation of energy from one form to another form? Okay, fine. Okay, a few hands do raise. Thanks for those who responded. Right. The next thing I would like to show is a mathematics problem. Okay, this is from a different site. Okay, in mathematics, let me open that mathematics link. Before that, I will also explain what is a histogram. Okay, Just give me a second. Now I'm going to share my screen on. This is again, this is not a. First, I'm going to show you on the Excel. I hope the Excel is visible to you all. Okay. Let me. Okay. Let me just slightly bring it down to 130. Okay. Now what I'm going to do is I'm going to have some numbers. I'm going to fill some numbers over here. To fill this number, I want to fill it something like between 10 and 50. Anybody knows how to fill a set of cells in Excel to have numbers between 10 and 50? It's very easy. Excel has got a lot of formula. If you use random between, it will ask you when the moment you put the equal sign and then say rand between, I'm going to say anything between 10 and 50. Okay. I'm putting that. I copy that to all the cells. So you could see a lot of values filled. Okay. Now this is randomly, Excel itself randomly did something. Okay. It's not that I did. So I copy this again, I put it over here. It randomly chooses. Either I have the option to manually type it, or you can make Excel to randomly do it. So this is how you can prepare data. Now I want to actually do a histogram. Again, everything need not be going through simulation, and you can also show through tools like this, because you have Google spreadsheets. You'll be teaching bar charts, you'll be teaching histograms. What is a histogram? Histogram is something like a continuous values I am putting into buckets, or I am putting into bar. So if I want to draw a chart, I select from here. Okay. Now I want to choose something like between 10 and 50. Okay. Sorry. Between 10 and 50, 10 and 20. Between 10 and 20, how many items are here? I have to manually count. There are totally 19 rows over here. Totally, there are 19 rows. Now, between 10 and 19, I want to put it into different buckets. If you choose here, manually, let me count. This is 1, 2, 3, okay, 4, 5. 5 items are between 10 and 20. Now I would say 21 and 30. What I want to do is 21 and 30. Now again I count 1, 2, 3. 3 items are here. 31, between 31 and 40. Now I want to count it. 1, 2, 3, 4, 5, 5. Okay. 41 and 50. If I count it over here, 1, 2, 3, 4, 5, 6. Now, if I count it, it has to come to totally 19, right? Because there are 19 items over here. I'm doing 5, 3, 5, 6. Now, I have to draw a graph between 10 and 20, between 21 and 30, between 31 and 40, between 41 and 50. So you draw a histogram like this. To do that, what we can do is you can choose this insert. You can choose insert and then choose a graph like this. Okay, more statistical charts. Okay, you can also click here. When you click here, it will tell recommended charts. What are the recommended charts? Excel itself will say, I want to have I am recommending this particular chart for you. Between 12 and 28, these many items. Between 28 and 44, these many items. Between 44 and 60, these many items. Excel automatically recommends. Okay. Here, what we try to do is drawing a chart based on the values. The histogram is also a bar. But what is the big thing is, you are saying 10 and 20, the intervals. This is called equal interval histograms between 10 and 20, 21 and 30, 31 and 40, 41 and 50. Suppose I want to say group 10 to 30 in one bucket, 31 to 45 in another bucket, 45 to 50 in another bucket. That is called unequal buckets or unequal intervals. So equal interval, when you talk about histograms, you will talk about equal intervals, right? It is better to have equal intervals. In some cases, you will also have unequal intervals. Now, I'm coming back to this. I come to OLAPs. In OLAPs, you have again, you can talk about histograms. Okay. You will have what is the type of histogram. So they know how to draw this procedure, what are the points that you have to give, and then what is the procedure to draw these diagrams, what is the animation. One good thing about more than FET, if you look at OLAPs, it gives a complete video also for that. Okay. Now you can also do simulation. When it comes to simulation, I think there is some problem over here. It is again that OLAP site itself is having some issue this evening. That's why it is not loading properly. Let me try to load it in another tab. Let me see if it loads. Maybe a lot of people are using it, seems. It's not, it's refusing to connect for this particular animation. So what I would suggest is you can use this simulator to draw that. Again, it's the same way that what we do in our Excel sheet. Now, one very good thing about OLAPs is any topic you choose, they have also given under self-evaluation what are the questions you need to ask. It talks about what is the which class interval has the minimum frequency, right? That means between 40 and 50, is it more? Between 10 and 20 is more. When I say frequency, more number of items. By seeing the picture, the kids should answer. Second question, which type of histograms represents a normal distribution? As and when you teach the subjects, it has given all the important questions with diagrams and answers. It is again a teaching aid so that it minimizes the work of the teachers. So you can teach through this at the same time. Do a simple 8 to 10 MCQ questions. You can also evaluate your class for 10 minutes rather than having an exam for 1 hour or 1.5 hours. Only this particular concept, just 10 questions, objective. You can do that. It is possible. Okay. This is also available in real time. OLAPs is also available in real time. Let me try to connect to the simulator once again and see. I'll try one other browser. Sometimes because of browser updates also it may happen. Again, it's not that okay. No, this is site is having some issue. Probably you may try after some time. Okay. So now let me stop here. Okay. Now a very simple question I am going to post in your chat box. I'm coming back to video. I'm going to post a question in your chat box. Okay. I think two people are saying voice is not coming properly. For the others, I hope the voice is clear. Ganesh, can you confirm? Uh, hope the voice is clear for other people. Can you please raise your hands or give some emojis to just to confirm that voice and video are clear for you? Can you share your emojis or raise your hands? I will wait for your answers. Okay. Now, okay, two people are able to raise. Okay, fine. Now, I'm going to post a question. Again, as I have told in the last class, we need to cultivate the analytical reasoning in the kids. And analytical reasoning or critical thinking doesn't come in one day. Along with our subjects, along with our regular day-to-day classroom sessions, we need to push these questions and then take it. Okay. I have posted a question. AMBNCODP. What is the next value? Can you type it? I have given 4 options. What is the option that, what is the next option? Can you, this is a very simple thing because this is like gradation or progression based on numbers, progression based on text. These are very simple questions. Our recommendation is that because any of the competitive exams, you name it JEE or JAM or GATE, right? Yeah. I have got 1 answer, 2 answers. Good. So the next value is capital E, small q, because the pattern is first letter is capital, second letter is small. If the kid has got the ability to get this detail, that is the important thing. First of all, the children should understand what is the pattern. Now they should pay attention also to the pattern. Accordingly, they will answer. Again, this may look very trivial for us, whereas for a 6th kid or a 7th kid, the moment they start thinking, we are creating the spark in the kids. So science or mathematics or English subject alone is not going to cut it. So we need to create the passion for analytical reasoning also in the kids. I just pushed this. Same way as teachers, we urge all of you, we request all of you to also every class, just to one question. Imagine the kid goes through 8 hours in a day. In 8 hours, if they have seen 8 questions, within a week, they would have seen 48 to 50 questions. That would create a lot of impact in the kids. This is exactly what we are looking at. Now I'm going to publish a poll. So far, we have seen a simulation or activity. We saw that energy change forms. Now I am clicking this poll. Okay. Let me just 1 second. Somewhere there is I'm not able to publish the poll once again. Okay. 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 Let me stop the poll. Let me start the next simulation to you. My request to you to you all is the participation today is very less. I could see the answers or hand raising only from very few people. Whereas in the last few classes, we could see a lot of people trying to raise the hands. Whereas today, I couldn't see that. Can you, is everything okay now in terms of internet and other stuff? Can someone answer? Internet stuff or other things are okay? Okay. Again, very few people are answering that. Not a problem. Okay. Let me once again come back. And then I'm going to show one other thing now. Let me jump to thing is girl. Again, this is not Lata or Rekha. It is not representing one particular girl. It is representing girl as a type. So it is common noun. If I wrongly choose a thing, as you know, right? India, is it proper noun or common noun? Now, suppose I say it's a common noun, it says it's not common noun. It is the correct answer is proper noun because it represents a particular nation. So car. So again, seeing the picture, reading the word, choosing the answer. This is a typical trick in any activity based lessons for languages. First, visual cognition. Second thing, seeing the letters and then reading it, then comprehending based on the question type. So this is a common noun. Now next thing is Elsa. This is a proper noun because it's representing one particular girl, right? Pepsi, again, it's a proper noun. So this is like showing the details and then making sure that some amount of comprehension is observed, is expected out of the students. Correct? And this can be used. I'm just stopping this exercise. This is one activity. Later in our classes, we are going to say, we are going to see and we are going to give training. Somebody has created this thing. Okay. And we are using this. I want to create my own thing. I want to show Charminar. I want to show zoo. I want to show lion. I want to create my own proper noun and common noun exercise. We will also see that. But initially, we are actually using what is there in the existing system. Okay. Now, I am going to show one other simulation in science today. Okay. Let me stop sharing. Electric circuits. In which grade it appears? Electric circuits. Creating an electric circuit. Is it in 7th standard or 6th standard? You can answer in the chat box. Is it which grade? I believe it's 7th grade, I think. 7th grade in electricity and magnetism, electricity circuit comes. Now, I want to show a circuit. Let me start showing you the circuit. Okay. I am sharing my screen. You are seeing a circuit. Just 1 second. Hope my screen is visible. I'll wait for somebody. It may be loading. So I'll wait. Let it load. Yeah. I want to create an electric circuit. So how do I make it? First, in our record notebook we will write apparatus required or equipment required. Now I need a battery, I take a battery. And I want to find out what is the voltage of this battery. To find the voltage, I have voltmeter with me. Voltage happens between two ends. రెండు end మధ్యల, right? That is the voltage between two ends. So this one battery shows 9 volts. Now I take one more battery. I want to connect them in serial connection. So serial means this positive and this negative together. That means I have connected. If I connect two batteries in series, voltage will be 9 plus 9, 18 volts. What if I connect them in parallel mode? Let us see. I want to disconnect, just click on it. A scissor will appear, it is detached. Now I have this battery and this battery. I take a wire, connect negative of these two batteries, take another wire, connect positive of these two batteries. Now find the voltage between these two, only 9 volts. So when you connect two batteries, each with 9 volts in parallel, it will be only 9 volts. Whereas if I connect two batteries in series, then it will be 9 plus 9, 18 volts. Okay. Now I remove it, just press delete button or this symbol. Select that object, remove this object. Now I connect these two batteries in series connection. So this is basic parallel and series connection of batteries. Now I take a wire. I want to make a circuit. I connect a wire. For the circuit, what else do you need? Oh, so okay, someone is typing switch. I need a switch. I type this switch. I connect this switch. Just drag and drop, push that into the particular position, automatically it will connect. Now I take an electric bulb. Typically this is what we will show the way to create a circuit. I take one more wire, connect chestanu. One more wire EN or EN lo connect chestanu. Correct? Now this is battery, switch, wire, bulb. I connected. What is the voltage here? It is 9 plus 9, 18 voltage. If I switch on, what will happen? Let us see. I expect the bulb to glow because the current will pass through that. Bulb should get brighter. Now I switch on. Bulb is not glowing. Battery is burning because I switch off. Reason is the bulb has two ends. What I did is connected both the wires to the same end. That means I have done a short circuiting. Since I did a short circuit, the bulb was not burning, the battery was burning. Now I properly connect. I take the bulb here. I connect this wire to this end. I connect this wire to this end. Now I switch on. The bulb glows. Okay. Now the bulb glows. So the circuit is complete. Now I want to measure what is the current passing through this circuit. I take this ammeter and I connect this here. Now it says 1.8 amperes. Voltage is 18 volts. Current is 1.8. You know Ohm's law. V by I is equal to R, resistance. Where is the resistance? Resistance, it is here. The resistance is in the filament. I want to know, I click on these values, you could see 10 ohms. This battery is 9 volts. This battery is 9 volts. This is 10 ohms. Current is 1.8. Voltage is 18. Now let me do one more thing. I am going to connect two bulbs in serial connection. You might have seen serial bulbs for decoration. Now I take two more bulbs. Okay. I take two more bulbs. I connect them in serial connection. Correct. Now you could see the bulbs are glowing, not that bright. Voltage is 18. Current is only 0.6 amperes because 10 plus 10 plus 10, 30 ohms resistance is there. Right? V by I, 18 divided by 30 ohms, you get this amperage, this current. So you can show how batteries can be connected in series or parallel, how bulbs can be connected in series or parallel. Correct. Now I want the bulbs to glow better. Now if you see these rays are only this sharp and then this long. Let me do one thing. Let me disconnect this. I am taking one more battery. Let me take one more battery. So 4 batteries I have connected. Now I connect. Now the bulbs are brighter, right? Now the bulbs are, previously the rays were shorter. Now it shows it is bright. So now I am calculating the amperage is this much. Voltage is 36 volts. 4 batteries connected in series connection. 3 bulbs connected in series connection. The voltage is 36 volts. Current is 1.2 amperes. Resistance is 30 ohms. Right? Again, you can do a whole lot of things. Now I connected batteries in series, bulbs in series. You can also do batteries in parallel, bulbs in series connection. Batteries in series, bulb in parallel connections. You can also attach resistors, right? So let me also show that. I disconnect this end. I am taking a resistor. A resistor will try to block the flow. So when I connect a resistor, obviously the bulbs will go dim. Now I connect this. Now the bulbs are getting dim. Now let me do one more thing. I am connecting one more resistor. See, bulbs have become very dim. So you can show batteries, switches, bulbs, resistors, proof of Ohm's law, everything you can show, and then you can ensure that people are getting the practical aspect. What is the advantage? I have connected all these things. I don't have to buy anything. Still, I can visualize the whole stuff. All I can simply do again, once I show to my students, reset, ask the students to come back and then take it. Let some other student come and then show. Not a problem. Okay. What I'm going to do now is I am stopping my screen. I come back to our webinar video screen. I am passing this URL to you in the chat box. I have passed this URL to you all. let us take a few minutes. I'm going to pause the recording. Okay. What I would suggest is we have finished all the 4 stuff that I have planned for today. Anything that you want to convey in the next 2-3 minutes, you can also convey through chat. Or if you want to talk, if there is if the external mic attached to this, or if you want to open your microphone and then give opinions, we are also open. You can raise your hands to talk. We can open the mic for you. We want to listen to you also. Let us wait for 2-3 minutes to hear from you all. Or you can convey your things on the chat also. Anyway, you have conveyed your interest levels on the poll. Thanks for that. And once again, we also thank all of you for staying back and then go through these capacity building exercises. This is going to be fully in terms of simulation and activity based learning only. Subject you already know. It is not to teach the subject because you are all subject matter experts already. This is only to ensure that how to use simulation and mix with subject, teach in an interesting way. Anything that you want to convey either through voice or chat, we are willing to listen to you. We will wait for a minute to hear from people. Otherwise, we can close after a minute if we don't hear. Anyway, I will wait. Time now is 4:57, and thanks for coming to this session. With that, we will close the session today. Once again, thanks. Jai Hind.